Got a little journey there for you to start things off. Alright, let's hope that you folks enjoy the new HD format. We're going to try this out today and see how it goes. And basically what we're going to do now is break down the pattern for the March 1st through 3rd storm, and why I believe that the Canadian right now has the best idea with this storm. And if anything, I still fear the inland track as opposed to the out to sea one. I think the GFS is out to lunch as it's not initializing the strength of the energy in the Pacific Northwest properly at all. And well, we'll just leave it at that. I'm not even going to look at the GFS. I think it's just wrong. I want to look at the Canadian, and then we're going to look at the Euro and the NAM and see why there's so much disagreement among the models, and where I think that some models may be making an error. So here's our Canadian initialization, 12Z today. These are all 12Z runs of the models, just to keep consistency here. You can see here's our cutoff piece of energy sitting in the Pacific Northwest and off British Columbia, and here's the second piece of energy, the second shortwave that's going to amplify this vortex in here and cause it to really dig down the system. And I think that pretty much all the models except the GFS agree that we are going to have a very strong polar vortex driving down into the northeast. And I don't think people who believe that the system's not going to phase are correct. I definitely see phasing occurring with this system, and a strong phase at that. Alright, let's move on to 6 hours or 12 hours from now. You can see this is one of the biggest keys and why I think the GFS is wrong. Look how strong this piece of energy is in here. The GFS just loses it and weakens it. So what happens? It brings it further across the north, and you get a weaker solution. But I do like what the Canadian's doing. Alright, on to 24. You can see it continuing to progress inland. 36. Here it goes. Here's our first wave out front. With the big coastal front that's going to be coming to the East Coast. A nice warm day across the entire East Coast, pretty much anywhere in this warm sector, which is the area I've sort of outlined in blue to the south and east of that, anywhere in here. So this is valid 0Z Friday, so I think Friday is going to be a very warm day. Now, one note about this front, where it ends up is absolutely key, because as we've seen so many times this year, this thing is going to develop along the baroclinic boundary. So wherever that front lays is where the storm's going to develop. So we'll have to see. Again, you can see the Canadian bringing it up into the lakes and progressing it here. And here you can see by the time we get to 0Z Saturday, it is the front lined out somewhere. Actually, that's incorrect. It is the front lined out somewhere right in there. And here's our next piece of energy cut off from the main flow. Here comes the shortwave around the backside, getting ready to dig into it. And if anything, considering the fact that this shortwave's sitting up over eastern Alaska, a very sparsely populated data region right now, I'd expect it to trend stronger on the models that we've seen constantly all year. I don't see any reason why we would break that trend, and that's going to indicate more phasing. Now again, remember what I'm forecasting here. I'm forecasting the possibility of a big East Coast snowstorm, but if anything, I expect there to be a further inland solution than even what the Canadian is showing. And here you can see the Canadian here starting to develop low pressure, and is going to track it up along the East Coast, as we'll see here in the next few frames. Moving on to the next frame, you can see our cutoff energy continuing to dive down. So here's the low beginning to develop. Where's the front? The front's way off the coast. Oops, front's way off the coast here. So where's our baroclinic boundary? It's right there, so the low is going to track right up along like that. And sure enough, when you look at the Canadian, that's exactly what it does. Here's the low in here over South Carolina. Once we get to 0Z Sunday, and now we're going to see precip breaking out all the way up into the DC area. This would be snow at this time. Look at how far south and how strong it is, this piece of energy. I think if anything, the Canadian's problem, it might correct this just a tiny bit north. I'd say it's going to be more in here, and the trough configuration with this might look something more like that. Well, actually, not like that, but more like this. I expect this piece of energy to be a little bit stronger, a little bit further south, this to be a little bit further north, and for the phase to occur even a little bit sooner than the Canadian's forecasting. Nevertheless, I think once this thing phases, wherever you are to the northwest of the track, this is going to be an extremely slow mover. It's going to be a dumper. Let's move on here. I'm going to try to keep this under 10 minutes today, but I don't think that's going to happen. Here we can see the low going up the coast, and heavy precip in DC. This is over an inch of liquid. DC and Philadelphia both, you're getting absolutely slammed. And here we go with the long duration storm, and here you can see, here's the vortex diving into the south, and you can see it just absolutely explodes and basically goes right over DC. And I think that that is a very reasonable track given what we're seeing. And the reason why, a couple things. Number one, let's back up for a second here on the Canadian. You can see here is the trough off the west coast. Look what happens. This piece of energy does not come inland. It dives south into the trough. And that is why we're able to amplify the ridge out front, and we can really get this thing to dig deep into the deep south. All right, enough with the Canadian. Let's move on to the European, and why I think that it's, well, not totally out to lunch, and its solution is actually very similar to the Canadian. It actually just has a little less phasing, and that's why we see it doing what it's doing. So let's bring up the European here. All right, starting out at 72 hours, because I don't have the earlier maps. Here you can see the piece of energy very similar to where the Canadian has it, low pressure, maybe just a bit further to the north and to the west. But the problem is it has this energy hanging back too much. Let me switch to a more easy to see color here. Is this piece of energy hanging back too much, which I expect it to really slide down more, and so you'll get more phasing to occur earlier. Moving on, continuing to look through the European here. Oops. I'm going to recenter that for you guys. You can see the piece of energy continuing to dive down. Here's the low, getting ready to go up along the coast. Next frame, 96 hours. Here it dives down almost to the exact same position the Canadian it has. But why is this low pressure so strung out? Because this is further back, which I think is an error, because the European is not phasing this back here as strongly, which again I believe is an error, not pumping the ridge in here as strongly, and so it keeps this piece of energy sitting back further over the Great Lakes. I do not believe that is correct. While this is certainly a possible solution, I don't think it is the most likely solution at this point. And now as we go on through to the 108 hour, and here's 120. And you can see the low basically riding up along the coast. All right, let's go ahead now and take a look at the NAM, and why I think its solution is also plausible, but why I think it has some critical errors in its thinking. Here we go, 0 hours, 12 hours. You can see it is not like the GFS. It keeps this thing much stronger, digs it further along the coast, and I think that's correct. And we continue here to 24 hours, 36, 48, and here you can see it's starting to reorganize it now. What the NAM is doing is it's jumping this out front. I don't believe that's correct, and I'll sort of explain why in a few moments, but continuing to go on here, here's 72. Oops, I skipped 60. Yeah, there's 60. 72. And again, with this in here, it develops low pressure further inland, and you get rain basically along the I-95 corridor. I don't think that's correct, and again, I will explain why. But you can look, it's digging the low further south, a la the Canadian, a la the European, and it has this feature in here, very much like the Canadian. In fact, I think it might be even more phased on the NAM, and I do like this solution. I think that it's correct. All right, so moving on here, and we'll just briefly take a look at the surface solution in here, and you can see the big rainstorm out along I-95. Now, here's why the NAM's doing what it's doing. It has this strong jet energy coming in over the west coast. That splits off a piece of the southern shortwave, and you get a more inland solution with the two separate shortwaves. I don't know if that's correct, but we'll see within 36 hours, as this is a 36-hour map, whether or not the NAM has an idea. So that's all for now. Just my ideas. We'll keep taking a look at it and see where things go.